Today we are going to discuss about numerical Python. Okay. Now NumPy stands for numerical. What is numerical Python? Well, numerical Python is nothing but a library which consists of multi-dimensional array objects, which is library, which consists of multi-dimensional array objects and collection of routines for processing those multi-dimensional arrays. Okay, so it basically what we can achieve through NumPy, we can perform mathematical and logical operations on arrays. Okay, and that is what we can basically we will be seeing today. Now NumPy is also said to be a replacement of MATLAB. Now NumPy, the operations which NumPy can perform are, as said, mathematical and logical operation. There's something called Fourier transformation and routine for shape manipulation and operations related to linear algebra. Okay, it is an open source. NumPy is an open source module of Python. NumPy often is used with scientific Python, which is known as science-py. So sci-fi is something which we would be discussing in classes to come. Okay. Now, in order to use NumPy, we need to install NumPy module. So it does not come by default with Python. Now, for Linux users or Mac OS users, you can, or even for Windows, you can install NumPy with this command. Now, in my case, it has been observed. It has been so for Linux and Mac OS, you can use this. For Windows, now if you guys are using Python on Windows, you need to download it from this site. There's a package available. You can download it. So this site offers free Python distribution for NumPy and SciencePy too. NumPy in the array. We are moving ahead. Now, one of the most important object of NumPy is n-dimensional array. Always remember, we will be using this array throughout our program, and it is also known as Ndarray. Now, what does it do? It describes the collection of the items of same type, which basically helps in accessing those collections from the zero-based index. Okay. The interesting fact in this is every item in the ND array, it takes the same size of the block in memory. So remember, in memory. Okay. Okay, it takes the same size of the block in the memory, and every element in Ndarray is an object of a data type object. Is an object of a data type. That data type is known as D type. So let me write it here. Every item of Ndarray takes the same size of the block in the memory, and every element in Ndarray is an object of data type, which is known as D type. Sorry. So any item which is extracted from the Ndarray. So how is the item extracted from the Ndarray? Items in Ndarray are extracted by a method called slicing, which we have discussed in our previous classes. Now, how does it look like? Show you a figure of it. Let me draw a figure of it precisely. That would be fine. Here it is. Now, our Ndarray basically comprises of this is my Ndarray. In my Ndarray, I have small blocks. These are the small blocks, like this. These blocks, they are known as headers. So let me write here. These blocks are known as headers. Every header basically takes the object, takes the data type, not this one. Every array basically takes the data type, which is D type. And this D type is, okay, it comprises of all the informations pertaining to the data. This D type instance of the Ndarray class, okay, which is constructed by combinations of different array creations, for array creation, the method which we use is Ndarray dot, NumPy dot array. Now, what will this do is that it will create an Ndarray from any object which is exposing the interface of the array. Yes, there are certain parameters of Ndarray. First one is they are object, which is nothing but the array interface method, dtype, which is the data type, copy, which is used for copying the object, order, with respect to ordering the data in form of row or column. Okay. Sub okay, which basically is used to return array in case the condition is true. ndmin, sorry, which is it specifies minimum dimension of the resultant array. Terminal window. This is the Python. I will import NumPy, not in this. Import NumPy. With a variable, I am defining an array, which is defined in a parenthesis along with a square bracket to define it as a list, elements in the list. And then I will, this output is nothing but a one-dimensional array. Now, what about a multi-dimensional array? Now, in that case, since I have already imported NumPy as NP, I don't need to. I can just perform a multi-dimensional array. What went wrong? Oh, np.array is, oh yes, my mistake. Multi-dimensional, right? This is my multi-dimensional array. Now we just saw ndmin specifies the dimensions. Okay, so an example of ndmin is for minimum dimensions which needs to be there. I can use this, my multi-dimensional array. ndmin. So here you would see, so what does my ndmin does? ndmin basically specifies the minimum dimension of the resultant array. So minimum dimension is 2. Since I have already defined into one dimension, so that's why I'm getting only one dimension. If I would have different dimensions, only two dimension resultant with respect to two dimensions would have been projected. Now, the data type parameter, which is the default data type, which is dtype. So what it comprises of? So data type can be complex, simple, or simple and complex. So complex basically is nothing but an imaginary number. How does data type parameter work? I have to define a data type deep type is equal to complex to see how it works. Okay. Now, since I don't have any imaginary number associated with my element, so it already by itself suffixed it as 1 plus 0 point dot j. Now, the most important, so these are few examples of this. Now, one of the most important is that the Ndarray object consists of continuous one-dimensional segment of computer memory combined with indexing scheme which map each item to a location in the memory block. Now, this memory block holds the element in row-wise or column-wise order. Now, row-wise order basically is nothing but the way the data is stored in C language, that is stored in row-wise. And column-wise order means the way the data is either stored in Fortran or MATLAB. Apart from the default data type D type, NumPy supports a lot of other variety of the numerical types as Python would do. So NumPy basically also supports variety of numerical types. Okay, now what are those? One is Boolean, which is shown here. So it is stored as a byte. Second is int, default integer type. Third is intc, so integer type. With int as int 32 or 64. Then intp, which is used for indexing. Five, int8, stored in byte with a range of -128 to 127. 6, int16, range -32768 to 32767. 7, int32, which is -2147 48368 to 2147 48367. Then we have int 64, range is higher. 9 is uint 8. Now here U stands for unsigned int, range 0 to 255. 10th uint 16, range 0 to 65535. Then we have uint 32, We have uint64. Then we have something called float. This is for float 64. Then we have called float 16, float 32, float 64. Sorry. Then we have complex, which is equivalent to complex 128-bit byte. Then complex 64. For 32-bit, two 32-bit floats, it is equivalent to and complex 128. These are the different variety of data types which I support. Now, there is a dtype object in NumPy, which is basically, what is a dtype object? First and foremost, a dtype object, or also known as data type object, basically it describes the interpretation of the fixed block of memory corresponding to an array, and it is dependent on certain aspects. What are those aspects? The type of the data, of course, the size of the data, the byte order, and in case we are having a structured type of data, then the fields, data type of the each fields, and the memory block taken by each field. And if the data type is sub-array, then the shape and data type. Here, the byte order for the data type object is decided by byte order for data type object is decided by prefixing this sign, greater than and less than sign, where my greater than sign, basically, it means that encoding is least significant, whereas this sign means my encoding is basically most significant. The syntax, so there has to be a syntax to define that. So the syntax for defining data type is numpy dot dtype object align and copy. Now where object is any data to be converted to data type object, align is to restructure the data to a format similar to that of C. Nothing to do with C language, just the structuring. And copy means makes a new copy of the type of. So we'll be using an array scalar type example, which will be a variable using int32 print. This is a scalar variable, okay, so no variable. So it will only give me int32. Similarly, I can do it with a string, equivalent string for int32 or 64 or 16. So there are equivalent strings for that, which starts with I1, I2, I3, I4. How it would go is, let's say if I have defined this equivalent string. This is how it is giving. It's a sort of a structured data type. Now, if I want to apply it to an array object, Ndarray object, what should I do? We have seen how it works. What should I do? So I have already imported it. Now I will just apply it to my Ndarray object. Where I have something called age, string, age as a data type definition, and then assigning a value is with a d type equal to dt, which is defined in the previous line. So this is how my int, which is a data type, has been applied to the data values which I have feed it. There's one more example which we are going to discuss. So there is a data type. There is a structured data type. Let's say there is a structured data type X, and it has a string field as name and an integer field as age and float field as mark. How do we apply this data type to an Ndarray output? So X instead of X, since it is marks, age, and name, so I'll just write student np.dtype name age and marks. I'm just applying it, not giving the values right now. Printing it. This is how it has been applied. Now I can pass on the values like this. So how do I pass on the values? I'll pass on the values. X, Y, Z, 18, 5, this with a D type, student, as I did it in the previous